of lesson 3.2, and we're going to go over example problem number 4. And so I modified the instructions to the homework a little bit on this video, but they're basically mean the same thing. We want part A, we want to find the supremum, we want to find the infimum, also known supremum or the least upper bound, infimum or the greatest lower bound, and state if the supremum for set S and infimum for set S are in set S. Okay, so here we have a problem that's similar to what's on the homework, where we have set S is a set where we have S sub n is equal to the summation of where I equals 1 to n for 1 over 4 to the I power, where n is 1, 2, and so on, continues on indefinitely. So if we started with n equal 1, right, then that would be I, the sum of I from 1 to 1 for 1/4 to the I power. So that'll just be 1/4 to the first, and so that's just 1/4. So now if we went to n equals 2, I equals 1 to 2, and this would be 1/4 I, then that would be 1/4 1 plus 1/4 squared, and so on. So we end up with 1/4 plus 1/16, and so we'd have to multiply 4 over 4 to get a common denominator, and so that would be 16 over 16 plus 1 over 16, and so we get 17 over 16, and so we slightly get something slightly larger than 1. So we continue with that. So this would be 16 over 16 times 4 times 1 over. So this is actually, we're multiplying 4 over 4 here. So this would be 4 over 16 plus 1 over 16. So that's 5 over 16. And so this is n equals 2. And so if we go n equals 3 and so on. So we want to figure out what is n, what's the largest number of n that we can accept, so that we can work with. So we want to go to the calculator, and what we want to do here is look at, first thing we have to do is change the mode. So if we go to mode, okay, and when we go to mode, we have to go down to function and then select sequence. Okay, and then sequence is going to get darkened in. As you can see, it was already there, but that's the steps. So our steps here are going to be mode, and then we're going to go down to function, and then sequence. Okay, so then we quit there, and now we want to put in sum. So we go to second and list and cursor over to math, and we want to select 5, which is sum. So that would be 5, and so now, so we get sum on here. So again, that's going to be second and a list, and then from second and list we're going to go to math, and then from math we're going to go to 5 and sum. Okay, and you could also cursor down to that as well and then hit sum, but I prefer to just hit the number. Okay, so this is what we've got so far. Now we want to go back to second and list and math again. So we're going to go to second and list. And this time we're going to go to ops. Instead of math, we're going to go to ops. So we don't select math, we select ops. And this time we're going to go to 5, which is sequence. 5, and then sequence. So we select 5. All right, so from here we go ahead and type in our expression, which is going to be 1/4 to the I power. So open parentheses, 1 divided by 4, close the parentheses, exponent, and then we select our variable. Here we select x. This is x, t, theta, and this will be, because we're in the sequence mode, it's going to select n instead of x. And then we type in our variable. We type in the x again, and it automatically puts in our variable as n. Since we're starting at I equals 1, we put 1 in here. And so we already did the first one, right? And then we could do 2 and so on. But it'd be more practical if we go ahead and put an end in, like, we'll choose a high number like 50. So basically what we're looking at here is n equals 50. So that would be 1/4 to the first power plus 1/4 to the second plus 1/4 to the third, all the way to 50, right? I equals 1 to 50 for 1/4 I. So that'd be 1/4 to the first plus 1/4 to the second plus 1/4 to the 50th power. Okay, so that would be pretty cumbersome to try to do that manually. So that's why we want to do that on the calculator. And we go step 1, we're going to do one integer at a time. And then we go down to paste and hit enter. And there we have our summation. Wait a minute. Something happened here. It only sequenced for some reason. So I'm just going to clear it and start over. So we're going to go to second, list, math, and sum. It's 5. And then we're going to go back to second and list and ops and hit sequence 5 again. And we already have our equation in there, our argument. And so all we have to do now at this point is go to paste. Now, so we go back, and now that looks right. Okay, so again, here's our variable, starting sequence, our start and our finish, completion, where n is, and then our steps or sequence is 1. So we hit enter, and we get 1/3 equals 0.3 repeating, or 1/3. So if we go to hit second and enter again, and this time we put 51 in there, we get the same thing. So our supremum is 1/3. Okay, so we can look at this. So let's take a look at what we have at this point. So here, if we look at this on a number line, we have Now 1/3 is obviously larger than 1/4. So our infimum is 1/4, our supremum is 1/3. And we have a definitive number. It's not like it's tending to anything, it's there. So that's going to be closed. And we have a definitive no matter how much we went 50 and 51, so that's also 1/3. And we have all numbers in between for set S. And we have our, so this is our B. So there's really no other B1, B2 because it stops there. And then this is our A, and there's A1, A2, and there's no other A's because it stops here. Okay, so so for our supremum, right, or least upper bound for set S, we're saying we want to define that. And so we have here a set S is not an empty set, has an upper bound, there's an upper bound B, exists, B is an element of all real numbers, such that for all X in set S, there exists a B, where X is less than or equal to B. Therefore, therefore, 3 dots for therefore, B is greater than or equal to, in this case, 1/4. Okay, which is our we're talking about supremum, so that's 1/3. Okay, so therefore the supremum for set S is 1/3, and we want to know, is the supremum for set S an element of set S? Well, because it's a definitive point, we would say yes. If it were open and we go closer and closer and closer and closer to it but never do get to it, then the answer would be no. But because this is a definitive point, the answer to this one is yes. Okay, so the greatest lower bound, or infimum, is